So let us start today's class. In today's class, we will be learning about introduction concept to pointers. Up to our last class, we learned about what actually function is, what are all the different types of arrays we have, all these things we learned. Now this is a new concept which is called as a pointer concept. Now why we need to go to the pointer concept and all we'll be learning in today's class. Normally what it was told, like for a C programming language, this is the backbone. The pointers concept is called as a backbone for the C programming language. And also it can be told like working with pointers is very hard also. So later on in other programming languages like Java and Python, completely the pointers concept has been removed. But if you take not only C programming language, the strength of C programming language is this pointers concept only. So let us see why we need to go to the pointers concept. Normally, whenever you store any variable, like let us consider any variable you declare, what happens? That variable will be holding that value. Like if you say int a, then a will be holding a variable, holding a value, and that value is of integer data type, right? Here also, if you consider, if you normally when you are storing any variable, any value in a variable, that variable will be allocated some memory. We have our memory. In that memory only we'll be storing our data, right? Now, pointer is also a variable. Now, what actually it will hold is it will hold the address rather than a value. Getting all of you, it is not storing any integer value, it is not storing any float value, it is not storing any character value. The pointer is also a variable. How the declaration and how the initialization will be done, we'll be going to learn that one also. But listen carefully, all of you. Pointer is nothing but a normal variable only. But what is the difference between a normal variable and a pointer variable is normal variable will be holding some value according to its data type. But whereas coming to a pointer variable, it will be holding the address. Now, what is the requirement of storing the address? It will be having so many useful applications like if you want to come out, define any variable outside the function, and if you want to access that variable outside the function, and that can be done easily by using our pointers concept. Right? That means enables us to access a variable that has been defined outside of your function. Outside of function, whatever variable we declare, that can be called as a global variable and that can be accessed easily. Okay, and between the functions, if you want to pass any information from one function to another function, that can be easily done by using your pointers concept. We already learned call by reference. Do you remember that one? Call by reference we have passed using the pointers concept. So any changes if you do in the function, that will reflect your original function variables also, isn't it or not? So if you want to have such thing, like if you want to pass the information back and forth between all the functions, then that can be done easily by using your pointers concept, and that is called as reference point. Okay, and if you want to handle data tables also, like a common data table is there, and that common data table will be accessed by all the functions, then it can be easily done by using your pointers concept. And if you use this pointers concept, the length and the complexity, the number of lines of code required to write your code will also be reduced if you use this pointers concept. And also, sometimes it will reduce the execution time also. That means the time required to execute your program will be less when compared to the other if you are not used. So it can also be said like it increases the execution speed. That means the time required to execute your program. That means converting your program to mission understandable format and getting the output. The time that is required to do that task will be very less when if you are using your pointers concept. So these are some of the applications, some of the useful applications that will allow us to use this pointers concept through this C programming language. Got it, all of you? And also one more thing you can also add to this applications is you will be directly accessing with the memory. So the amount of time required to get your data from the memory will also be very less when compared to the normal way you are getting the variable value. Like if you are trying to get the variable value using a variable name itself A, then for that some time is required. But if you use the address of A, then instead of searching the complete memory, directly it will go to that memory location and it will be getting the value. So because of that, the amount of time required to access a variable is also very less when you are using this pointers concept. So that is one more useful application you can add to this list. Okay, so these are all some of the useful applications. Now we'll see a basic concept behind this pointer concept. So whenever you take any variable, then what happens? Let us consider int a. That variable will be stored in the memory. Stored in the memory, what do you mean by that word? It will be occupying one memory location. If it is a normal variable, it will occupy one memory location. If it is an array, it will occupy continuous memory location. Isn't it or not? So whenever you declare any variable, then what happens? The computer will allocate, the compiler will allocate one memory location for that variable to store that value. Isn't it or not? So what happens? Let us consider if you are storing int a, then what happens? Int a will require integer data type capacities of 2 bytes. Then 2 bytes of memory cells will be allocated. So that will be allocated continuously. So the number of memory cells required to store the data depends upon its data type, whatever we are using at the time of declaration. For character, it will be of 1 byte. For float int, it will be of 2 bytes, like that. You all know that one. So depending upon that, memory will be allocated. And then each byte, whatever we are considering, each byte in the memory will be having its unique address. Okay, all of you, unique is nothing but whatever memory you have, each and every memory location will be having a unique address, and that unique address is normally represented by using numbers only. Okay, and whenever you are declaring any variable, this task will be done, like allocating the memory, and the allocation will be depending upon its data type. So if it is of integer data type, 2 bytes will be allocated. If it is a normal variable, only 2 bytes. If it is an array variable, depending upon the number of values you are storing, that many number of 2 bytes of memory will be allocated. Got it, all of you? So once this memory allocation is done, let us see one example. Let us consider you have declared int xyz equal to 50. You have done the initialization and all, you have done the declaration, and also parallelly you have done the initialization for a variable called xyz. Now here what can we say? This statement will tell to the compiler, like, I am using a variable called xyz and I want to store a value called 50, and to do this task, allocate me some memory, okay, in some location, and in that location put this 50 into that memory. And how many bytes of memory will be allocated? 2 bytes, because it is of integer data type. Got all of you? So whenever you write a statement like this, the compiler will allocate some location in the memory, and in that location 50 will be stored. And memory will be allocated means, what do you mean by that one? For that memory location, one address will be there, that is called as a address. See here. So suppose that address location is 1380. That means we will be having one. I'll write here. Let us consider what happens. One memory location will be allocated. In that memory location, 50 will be stored, and this memory location will be given an address of 1380. Right? So now what can we say? XYZ is our variable name, and 50 is the value of that variable, and 1380 is the address of that location. I hope you all are understanding these three names. Variable is nothing but the name of that variable. Value is nothing but whatever we are storing in that memory location, and then address is nothing but the unique address that has been allocated to this memory location. Got it, all of you? So this is how, whenever a variable is declared, internally this will be done, like allocating one memory address. Okay. Now what happens during the execution of the program? Whenever you're executing that program, the name with that address, like you can see here, 50 can be accessed. Whatever 50 you have allocated, like this we have allocated no 50, and 1380 we have allocated, right? And whenever you want to get this value of 50, that value can be directly accessed by using XYZ name, or else that value can also be accessed by using your address also. What is your address? 1380. Okay, remember, always the address is nothing but, it will be like simply numbers only, but it will be assigned to some variable. Whenever you want to access through the address, I'm telling you, 50 can be accessed by using your variable name or else by using this address. But if you want to access through this address, then this address should be stored in some variable. In some variable it has to be stored, and that variable is called as your pointer variable. Right, all of you? So such variables which are holding the address are called as a pointers. Make a definition, note down the definition, all of you. A variable which will be holding the address is nothing but a pointer. Suppose if you want to access the value of the 50, the value of 50 can be accessed through this address also. That means this address has to be stored in some variable, and that variable which is holding the address is called as a pointer. So pointers can be defined as a normal variable only, but it will be holding the address. It is not holding the value. It will be holding the address of our memory location. Right? Note down the definition, all of you, like this. So a pointer is defined as a variable which will be holding the address of a variable. Now, since since we are saying the pointer is also a variable, then what we can say? Since we are saying the pointer is also variable where it is holding the address, that means for pointer also one memory location will be allocated. So that is the thing, but I'll show you here. Follow carefully, all of you. This is your 50, right? And this is 13, what we have given 1380. Now I am telling this will be pointed by whom? This will be given by X, Y, Z. Right now I am telling by using XYZ 50 will be accessed. If you want to use this memory 1380 also, then 1380 should be stored in a pointer variable. That means one more memory location will be allocated, and that will be holding the value 1380, and it will be pointed by your variable call. Let us call that variable is P, and this P will be also given one address. Let us call that address is some random address I am giving 2002. That is what it is telling. Since a pointer is also a variable, its value is also stored in some memory location. And what is the value of that one? That value will be the address of this variable. So observe the difference. Here 50 is a normal integer value, but 1380 is a address. It is not a normal variable. Here P is called as a pointer variable. XYZ is called as a normal integer variable. That is the difference you all need to understand. Right? So pointer is a variable which will be holding the address of some another normal variable, and pointer will also be allocated some memory location to store that address, and for that also one new memory address will be given. Got it, all of you? Now let us consider one simple example. Suppose we want to assign the address, like you want to assign this address to this pointer variable. Then how can we assign that one? You can do that one by using, like you want to point the address, the same thing you want to do like this. P want to store the address of 1380. That means address of XYZ. How that can be done? You can do that one by simply writing like this. P equal to ampersand of XYZ. If you write like this, that means whatever 50 we have, and this 50 is given 1380. Now, whenever you write like this, whenever you write a statement like this, P equal to ampersand XYZ, then one new memory location will be allocated to P. Ampersand of XYZ is nothing but address of XYZ. What is the address of XYZ? 1380. That will be stored in P. That means in this memory location, we will be storing the address of XYZ. Got all of you? This is how you can assign an address of a variable by to a pointer variable called P, and that can be done by using your AND operator. Okay, AND operator can be used, and XYZ is nothing but address of XYZ. Right? So if you see here, now from this, what can we see? How many variables we have? XYZ is one variable, P is one variable. That is what we are writing here. Now, what is the value of XYZ? The value of XYZ is 50. And what is the value of P? 1380. Now, what is the address of XYZ? Address of X is 1380. And here I have taken a random value, any value you can consider. Let us consider 2325. 45 is the address of your pointer variable. This table you all understand. I think you all understanding this one. What is nothing but normal variable? What is nothing but pointer variable? Normal variable will be holding a value and a pointer value will be holding an address of another variable. How can we assign the address of another variable? Using this AND operator. Got it, all of you? So this is how a normal, we can assign an address of a normal variable to a pointer variable. Okay, so you can understand whatever I have represented here, the same thing I am representing here. Memory location with 50 value and 1380 is the address and it will be pointed by XYZ. And 1380 has been stored into one more new memory location and its address is 2545 and it is pointed by the P. Observe the difference here. Here XYZ is a normal variable and P is here a pointer variable. Okay, so always if you want to assign any address of a variable to a point variable, I already told you we need to use this AND operator. So AND is immediately preceded before a variable. Why? Because we want to give its address. So what we can do? We can use this statement P equal to ampersand of XYZ. That means we are trying to store the address of XYZ, which is in our case 1380, will be assigned to P. That is what I told you here. Got it, all of you? You can use this AND operator with a normal variable or with array elements also. Normal variable will be holding one value only. Array will be holding more than one value. So this AND operator can be used with normal variable like this. The distance, if you consider a variable name, you can use ampersand distance like ampersand XYZ, or else you can use for individual array elements also ampersand X of 0, ampersand X of 1, like that also you can use. So AND operator can be used with simply a normal variable or with an array elements. But whenever you are using an ampersand operator, make sure some points you need to remember where these things, whatever I'm going to highlight, those are illegal. That means invalid. You will be getting error whenever you are using those things. What are the things? Directly giving ampersand of 235, like directly giving a constant value. You can't give a constant value. You can't refer a constant value using this ampersand symbol. But if you want to access, you need to store 235 into some variable and then you can write ampersand of that variable name, let us call B. That means you can see B equal to 235. You can write like this. And you can write ampersand of B, but you should not write ampersand of directly that variable. This is illegal. You can't use that one, right? And int array of 20, if you are writing, then this is okay. If you have declared like this, this is okay. And ampersand of ARR of 0, ampersand of ARR of 1, ampersand of ARR of 2, like individual array elements, ampersand can be combined, but you can't directly use like this. Pointing to directly array name cannot be used. This is also an illegal statement in our C programming language. Okay. And one more thing, if you are combining with some expression, it's also illegal. You cannot use this ampersand symbol with an expression. Make a note of all these three things. Ampersand cannot be used with a constant. Ampersand cannot be pointed to an array name directly, but individual elements can be done. And ampersand cannot be pointed with an expression also. So these three things cannot be used whenever you are using, whenever you want to refer any address of a particular thing, right? So let us see a simple example how the memory will be allocated. Understand carefully, all of you, what we have done here. Okay. As of now, I have not started how to declare a pointer, how to initialize the pointer. All those things we'll be learning. But now what I'm going to make you people understand is what actually pointer is nothing but. Okay. So let us take 4 variable. One integer A is one variable and float B and C. Like this 4 data type, 5 elements in total I have declared. Now each variable is assigned some value. All this statement is all of you are clear with that. Now whenever you are writing a statement like this, then what happens? Internally memory will be allocated for A, for B. Are you understanding? For C and for D and for CH also. For D and for CH also memory will be allocated. And in each memory location, whatever value you are giving, that will be stored. For A, 10 is given, 10 will be stored. And for B, 2.5 will be stored. Okay, and for C 12.36, like that values will be stored. Whenever you are allocating memory, that means one address will be given. This will be the address. So what will be the address? That depends on, that will be a random value. If you run in your program, you will be getting different address. If you once again run in your same computer, you will be getting different address. But also that memory address will be allocated for each memory location. Now, if you observe here, what I am doing, I am trying to display percentage %d. That means first value A is stored in memory location ampersand A. Whenever you are writing ampersand A, what do you mean by that one? We are trying to get the address. If you are writing only A, it is nothing but we are trying to get the value. But if you are writing ampersand A, that is nothing but we are trying to get the address whatever we have assigned here. Now here, whenever you want to get the address, the format specifier we need to use is percentage %u. Make a note of that on all of you. Percentage %d and percentage %f, percentage %ld, percentage %c. These are the format specifiers to get the values of integer, float, double and character values. But if you want to get the address ampersand A, then we need to use the format specifier percentage %u. For percentage %u is a format specifier which is used to display the address. Okay. Now, if you see here, what we are doing, if you see here, first statement, this statement we are trying to print the value of A. That means I want to get the statement like A is, what is the value of A? 10. 10 is stored in the location. Whatever memory will be allocated according to your computer, that memory address will come here. Similarly, next statement we will be getting in the next line. B value, this will be represented here. B value is 2.5 is stored in the memory in the location. Whatever address is allocated for that one, that will be stored. That means this memory address, whatever we get. Similarly, you'll be getting 5 lines of code, and for all the 5 lines of code, in the memory locations will be allocated. So I have run this program, and this is what the memory address is allocated. So 10 is stored. If you see here, what is the first line? 10 is stored in location. You will be getting the address because we need to use a percentage %u because we are using ampersand A. Okay, so this is the address allocated for A. Okay, and similarly B value is 2.50 is stored in this memory location. Okay, so here you can see here there is an like these memory locations are allocated like that, and that means this is for A, this is for B, this is for C, this is for D, and this is for CH. Remember, these values may not be same for all the things. Why? Because it depends upon your system, where the compiler can store your data anywhere in your system. Where it has been stored, that value will be given here. And whenever you want to use, only thing you need to understand here is you need to use percentage %u as your format specifier. Got it? So this is how you can access the address. You can access the address of an individual variable by using your ampersand symbol. We have not used the pointers concept as of now. We are using the ampersand symbol. Got it, all of you? So this is how this program can be used to display the value and address of a particular variable using your AND operator. That means ampersand symbol. Right? So this is how this can be done. I hope you all are clear with these concepts, how a variable value and an address can be accessed by using your ampersand symbol, that is your AND operator. Got all of you? Is there any doubts? You let me know in the chat box.